The role of choke coils in electronics. Filtering, protection, and stability. Explained. What is a choke coil? A choke coil is a special type of inductor designed primarily to block or choke high-frequency alternating current, AC, while allowing low-frequency currents or direct current, DC, to pass through. Think of it as a gatekeeper in electronics. It doesn't completely stop AC, but it resists the fast, noisy parts of the signal, taming them so they don't interfere with the main operation of the circuit. It gets its name from its job, to choke unwanted currents, such as noise, spikes, or harmonics, and let the useful energy flow smoothly. How it works, without formulas. A choke coil is essentially a wire wound into a coil, sometimes around a magnetic core, like iron, ferrite, or powder metal, and sometimes with no core, air core. When current passes through, the coil generates a magnetic field. This magnetic field resists quick changes in current, especially those from high-frequency signals. So, while your steady current, like DC or low-frequency power, flows comfortably, the high-frequency noise gets trapped, absorbed, or redirected. In plain words, a choke coil is like a bouncer at a club. It lets in the regular guests the steady current, but throws out the rowdy troublemakers, high-frequency spikes, and noise. Where you'll find them. Choke coils are everywhere, though they often sit quietly in the background. You'll spot them in power supplies, to filter noise before it reaches your laptop or phone, audio equipment to prevent hums and interference, radio transmitters and receivers to separate useful signals from static, industrial machines to protect circuits from power surges, lighting systems like fluorescent lamps to control current flow. Why they matter. Electronics is all about precision. Even the tiniest unwanted ripple or noise can cause distortion, overheating, or outright malfunction. The choke coil steps in as a shield of stability, ensuring devices don't just work, but work smoothly and reliably. Without choke coils, your computer could crash more often from power noise. Your music could sound distorted by hums. Communication systems could be overwhelmed by interference. Sensitive electronics could burn out from current spikes. In summary, a choke coil is a protective filter. It doesn't just store energy like a regular inductor. It filters, guards, and stabilizes electronic systems against the chaos of unwanted high-frequency signals. The function of choke coils. The choke coil is not just another passive component in electronics. It is a guardian of order within the storm of electricity. To understand its true importance, we must look closely at its two central functions, filtering and protection. 1. Filtering, the art of smoothing currents. When electrical energy flows, it is rarely calm and steady, like a rushing river. It often carries turbulence in the form of noise, ripples, and high-frequency disturbances. Left unchecked, these disturbances can invade sensitive electronics, causing errors, distortion, or even failure. The choke coil's first duty is to filter these disturbances out. How it works. When high-frequency currents attempt to pass through, the choke coil resists them, slowing them down, absorbing them, or diverting them. Meanwhile, the steady, low-frequency or direct current is allowed to pass through with little opposition. Why it matters. This selective behavior turns the choke coil into a natural filter. In power supplies, it smooths the flow of energy so that devices receive stable voltage. In audio systems, it eliminates unwanted hums. In communication circuits, it silences static, making the message clear. In short, filtering is about purity. The choke coil ensures that what comes out of the system is clean, stable, and free from the impurities of electrical noise. 2. Protection, the shield against chaos. Electricity is unpredictable. Power surges, sudden spikes, or interference from nearby devices can all attack a circuit without warning. The second great function of the choke coil is to protect the system. How it works. The choke coil does this by resisting rapid changes in current. When a sudden surge of high-frequency energy tries to force its way in, the coil's magnetic field rises against it, absorbing the shock and preventing it from reaching delicate components. Why it matters. Imagine plugging your phone charger into a wall socket during a lightning storm. Without some form of protection, that spike of energy could destroy the charger and the phone. But with a choke coil in the circuit, much of that destructive force is dampened before it can cause harm. Protection is not just about safety, it's about longevity. By guarding against the hidden violence of surges and interference, choke coils help electronics last longer, run more reliably, and resist breakdowns. Filtering and protection working together. It's tempting to think of these two functions separately, but in truth, they are two sides of the same coin. Filtering keeps the current clean. Protection keeps the system safe. Together, they ensure that electronic devices are not only functional, but also resilient. A choke coil, then, is both a purifier and a shield. It refines energy so it can be used without distortion. It guards circuits so they can endure the unpredictable. This dual role makes the choke coil one of the unsung heroes of modern electronics. Without it, the devices we rely on daily, from computers to communication systems, would stumble under the weight of noise and chaos. The strength of choke coils. If the choke coil were a character in the world of electronics, it would not be flashy or glamorous. It doesn't dazzle with speed like a microprocessor or store endless memory like a hard drive. Instead, it embodies something far more enduring. Strength through resilience. The strength of a choke coil lies not in complexity, but in its simple, steadfast ability to perform under conditions where other components might falter. Let's explore these strengths in detail. 1. Reliability in harsh conditions. One of the greatest strengths of choke coils is their durability. Built with sturdy windings of copper wire and cores of iron, ferrite, or air, they can withstand high currents in difficult electrical environments. Unlike delicate microchips that may burn out with a single surge, choke coils are robust enough to endure electrical stress. Example, in industrial machines, where motors start and stop with heavy jolts of current, choke coils remain unfazed. They absorb the shocks, tame the spikes, and keep the system running smoothly. 2. Simplicity with power. Another strength is their elegant simplicity. A choke coil is essentially just a coil of wire, yet the simple design carries enormous power. There are no moving parts to wear down, no software to fail, no batteries to run dry. This simplicity means they are easy to design, build, and integrate into circuits, while still providing functions critical to the health of electronics. Think of it like this. A choke coil is to electronics what a seatbelt is to a car. It's simple, you rarely notice it, but it protects you when you need it most. 3. High efficiency in noise control. Noise is the invisible enemy of modern electronics. A system can have the fastest processor or the brightest display, but if noise sneaks into the circuit, performance suffers. Choke coils excel at efficient noise suppression. They filter high-frequency interference without significantly wasting energy. They help ensure that devices function at their best possible performance by keeping the signal clean. This makes them especially valuable in communication devices, audio systems, and sensitive measuring equipment. 4. Versatility across applications. From power supplies to radio transmitters, from lighting systems to computers, choke coils are adaptable to countless applications. This versatility is a strength that ensures they remain relevant even as technology evolves. In power supplies, they stabilize voltage. In audio systems, they remove hums. In communication equipment, they silence interference. In industrial systems, they protect against heavy surges. Few components are so widely useful across such a vast range of technologies. 5. Silent guardianship. Perhaps the most overlooked strength of choke coils is their silence. They don't announce their presence. They don't demand attention. They simply work quietly in the background, ensuring that everything else functions properly. Without them, our electronics would be plagued with errors, hums, crashes, and failures. With them, devices operate seamlessly, and most users never even realize the choke coil was there. In summary, the strengths of choke coils can be summarized in 3 words: resilience, simplicity, and reliability. They endure where others fail. They do complex work with simple design. They protect, filter, and stabilize without ever demanding recognition. The choke coil's true strength lies in the fact that, though often invisible, it is indispensable. Like a foundation in a building, you rarely see it, but everything else depends on it. The role of choke coils in electronics. If Chapter 3 showed us the inner strengths of choke coils, then Chapter 4 is where those strengths are put to work. Every electronic component has a role to play, like actors in a performance. Resistors manage balance, capacitors store a burst of energy, and diodes keep current moving in one direction. The choke coil's role is unique. It is both a filter and a guardian, ensuring harmony in the flow of electricity. Let's dive deeper into the specific roles choke coils play in electronic systems. 1. The guardian of power supplies. Modern devices, laptops, phones, televisions, all depend on power supplies that convert raw electricity into smooth, usable energy. But raw electricity from the mains is messy. It carries ripples, fluctuations, and noise. Role of the choke coil. The choke coil steps in as a filter, blocking out the ripples of alternating current that sneak through. It ensures the power that reaches your device is smooth and stable. Example: without choke coils, your laptop screen might flicker, your phone could overheat while charging, and sensitive microchips could fail prematurely. By smoothing out the power, choke coils act like shock absorbers for electricity. 2. The noise suppressor in communication systems. Communication devices, radios, TVs, Wi-Fi routers, rely on clear signals, but the airwaves are full of interference from countless sources: motors, fluorescent lamps, other transmitters. Role of the choke coil. In these systems, choke coils block unwanted high-frequency interference while allowing the intended signal to pass. They make sure your radio plays music instead of static, your router sends data instead of distortion, and your microphone transmits voice instead of electrical buzz. Example: imagine a radio broadcast filled with static. The choke coil works like noise-canceling headphones, eliminating the unwanted chatter, so the message is crystal clear. 3. The protector of sensitive circuits. Electronics are vulnerable to sudden changes in current. A power surge, a lightning strike, or even just the switching on of a heavy appliance nearby can introduce damaging spikes. Role of the choke coil. It resists rapid changes in current, protecting delicate components from being fried. Think of it as a surge guard built right into the circuit. Example: in medical equipment like ECG machines or MRI scanners, choke coils prevent interference and spikes from damaging sensors. Without them, patient readings could be corrupted, or worse, the equipment could fail mid-use. 4. The silent partner in audio systems. Musicians and audiophiles know that even the tiniest hum or distortion can ruin a sound experience. Electrical hum, often at 50 or 60 hertz from power lines, can leak into audio systems, creating unwanted background noise. Role of the choke coil. In amplifiers, speakers, and studio equipment, choke coils filter out this hum, ensuring only the music passes through. Example: imagine listening to a violin solo. Without a choke coil, the delicate notes could be masked by an ugly, low-pitched buzz. With it, the sound is pure and immersive. 5. The stabilizer in industrial machines. Factories are full of motors, welders, and heavy electrical loads that generate chaotic currents. If these disturbances reach control systems, they would cause breakdowns, errors, and costly downtime. Role of the choke coil. In industrial machines, choke coils stabilize currents, protect control systems, and keep operations running smoothly under heavy electrical stress. Example: in a factory where a motor starts with a huge inrush of current, the choke coil absorbs the surge, preventing sensitive electronics from collapsing under pressure. 6. The unsung hero of everyday devices. From LED lighting to chargers, from washing machines to televisions, choke coils silently protect and filter. Most people will never see them. They are tucked inside plastic casings and metal enclosures. Yet, without their role, devices would be noisier, less reliable, and far more prone to failure. In summary, the choke coil's role can be described in 3 words: filter, protect, stabilize. It filters unwanted frequencies, ensuring clarity. It protects circuits from sudden surges, ensuring safety. It stabilizes the flow of energy, ensuring reliability. Its role is humble, but its impact is vast. Every time your devices turn on without a flicker, every time your audio plays without hum, every time your call connects without interference, a choke coil has quietly played its part.